My name is Pei-Hsuan. It's easy to remember my name. It's just being patient with me. And the title of my paper is Detecting Scoreboard Updates to Increase the Accuracy of Machine Learning Automatic Extractions of Highlights in Badminton Game. So the context in my study is in the badminton game, and we collect the data from the very important international badminton games, so that we could really get the data that all have the same format of showing where are the scoreboard and how they will update the scoreboard. So that could be more consistency when we are collecting the data. And even that we show this context, and then we really wanted to measure the accuracy, how we will be able to extract those highlights for the people who are like to watch the badminton game, but they do not have time, but they really wanted to see those highlights. And if you wanted to download the paper, you can use in your cell phone to scan the QR code. You could directly download the paper, this individual paper from this scanning this QR code. And then we have other two authors, my students, and one student is I'm from National Zhenji University, and the other students, the last one, Mr. Huang, he is from National Tsinghua University. And all of our three authors are from Taiwan. So why we wanted to do this study is because we enjoy playing the badminton a lot, especially the second author, and that he is really good at playing badminton. He watched the badminton matches a lot online. Sometimes he loses patience, and so he really wanted to provide those highlights real time for the people, no matter they want to watch the game during the session or maybe after their work. Well, but even you're watching the game, sometimes you will, distracted by other things. So extracting the highlights seems that very critical to most badminton player or the fans, that when they are watching those very long duration time of the badminton matches, especially when you are watching the videos online, you always easily get distracted. So this is how we wanted to do this study. There are also different studies that are in the sports. They are trying to catch those highlights in different sports and different contexts, and trying to see how we could train the player. But this is not our study focus. Our study focus is that we really want to have the badminton fan to really see those highlights. Okay, so we have to move our focus from this badminton context to the object detection technologies. We have to review most of the literature regarding the object detections. So what are the models that could help us to detect the badminton shuttlecock? The shuttlecock is very small, it's very tiny. Because looking at comparing with this racket, and the ball is like this. So when you see this ball is in the field, in the playground, maybe it will be detect as a tissue paper. It may not be a real ball that we wanted to detect. That is the problems that we encounter when we're trying to using object detection technology to do these studies. And we also consider that sometimes the player, they will wear some white t-shirt, or the playground, they're using the white light, the white lines to evaluate whether that your ball is inside the field or outside of the field. So this kind of the color will also influence the way that how we detect the objects. We also review different kinds of the models like I listed here, and then so finally we used YOLO. You only look once, and compare with other model. And I will give you a very brief introductions of these models. Each model has their advantages and also have some disadvantages that prevent us to using those models. The YOLO have different versions. In our when we are carrying out the study, the YOLO version 5 is considered as the better model for us. Right now, YOLO is version 8, but now we are when we are carrying out this study, we're using YOLO version 5. And the full name of the YOLO is You Only Look Once. And then the differences between YOLO and other model is that YOLO only looking at the features, and then the YOLO do not consider about the region, that when we need to trying to square or trying to label those region of the scoreboard, since that we really wanted to know when the scoreboard changed, that we have be able to catch those highlights. Okay, so that is, we start from there, from the reason why we want to do this study and how we go to the object detection and find those difficulties when we really wanted to detect this small size object. And we found that YOLO can help us to finish this study. And so this is our research purpose. I underscore the last point is because this is our overall, the main purposes is to detect the highlight and accurately to detect the highlight throughout the entire game. So when the video is playing, that can automatically detect the highlights and then catch those, extract those video clips and then collect them together and then to play all those highlights for the fans when they wanted to watch all of those highlights during the game or after the game. And there are also other research purposes that we may have achieved. For example, that we review the literature, so we will be able to know the differences among different models. So we know how different models, they capture the highlights. And we also know that YOLO version 5 compared with other models can help us to detect the small size object. We also know what are the key features that will help us to detect those small size objects in this context, specifically in this study context. And we also know that the YOLO version 5 auto detection model can really help us to capture the highlights. And so while that we finally achieving our main purposes is to accurately detect the highlights throughout the game, then we also achieve all of these research purposes. And so we really wanted to share our research finding. But before we share all of the procedures and also the finding, and let's quickly review all of those models that we have been seeing in the literature. If you go to the paper, if you by scanning this QR code, you will see that there's a table, a very big, large table, that we carefully review all of the research and doing the sports highlights, related to the sports highlights. And then from those research, that's how we found those models. And we compare each one of them, and then to finally find that YOLO will be a better model. So the first one is GNN, and then you could see that I listed 2 bulletin points here because I share with you that how it's really nice, why we need to use this model, and why it will become a problem for us if we wanted to adopt this model. Such as CNN and RNN, they are deep learning models, and however CNN is used to process structural data, RNN is mainly used to process time series data. And if you're using some researchers, when we review the literature, they combine CNN and RNN together. Then you can see that it's required large sample size. It's not possible for us to collect the large sample size from the badminton games. We don't see, so far we do not be able to find that kind of a data set for us. And then for the RNN, it's really hard to say long-term data. And after the model has learned from the pre-processing procedures. And we also see there's also another RNN model. It's called short-term memory, but it's also still suitable for time series research. And so after that, we finally find other kinds of different models, but we find that YOLO, You Only Look Once, looks really, really suitable for us. We have mentioned that you don't really need to restrict the region of the specific object that you wanted to detect. So it's a region-free method. When we say region-free method, it's actually also called a single stage or one stage model. And you can using the YOLO to identify the position and the category of an object in a picture after it just look once, so one glance. And this is the model of the YOLO, and then it's published in 2015. If I remember correctly, it's on page 6. Page 6, if you go to the paper, you could also see this model. So we collect the data by ourselves, manually collected from all of these international matches, and we capture those game frames. So from each one of the game is a video clips, and then we capture those video clips into a frame, a lot of frames, and 10,000 game frame, and with the same size in the PNG format to make sure it's all consistent. And then we prepare the data in these procedures. And this is how we started to help the YOLO to learn from those data. And so these are our labeled matches photos. And then by following all of these procedures, and I highlighted using the yellow highlighter, and to help you understand how each one of the steps from this diagram, the model building procedures, to finally be able to help us export the short highlights videos. This is how we do it, by setting different parameters and then to calculate it, using the Python and to do the programming and help us to calculate the scores and also automatically extract those short period of time of the highlights from those video clips. The video clips has to be trained by, just like I mentioned, from the images, and then go back to the video clips and then to extract those video clips, 10 seconds of the video clip. Before that, the one side of the team, they really hit the ball and then win that matches, and then to get the score, and then the scoreboard get changes. There are different sizes of the different designs of the scoreboard. That's also another challenges, but that's another technical details that we have provided in our paper, so you could take a look. And this is how we evaluate the model performance using the accuracy rate. And then when we wanted to make sure that our accuracy rate is consistent, we try 5 different clips, the video clips. While the video clips are playing, that the model starts to looking at once and using the YOLO version 5, and then to see how accurate it is. It's not high, but it's very satisfied in our current research progress. It's overall reaching 70% of the accuracy. It means that when we are looking at those video clips, if we manually know that there is a scoreboard change, one team win the game, and then the 10 seconds of the video should go back and to replay those video clips and have the fans to be able to watch that highlight again. So it's overall 5 tests, and then we're reaching 70% of the accuracy. And the last 2 slides, we wanted to discuss about our small projects. Even though that we have already reached 70% of the accuracy and above, still very time consuming. When the YOLO version 5 is trying to watch those videos once, and it still it takes time. And we also find that it's probably because of the hardware devices. We also consider because we have to consider about where is the scoreboard that the YOLO model has to detect first. And then when we are calculating, when the YOLO model detects there is the scoreboard has to be cut in half. So all of these calculations, cutting that half, and then to make sure that the score get changed. Once the score get changed, then the video clip go back 10 seconds. So all of these computation times that will make this happening, the time consuming when the YOLO version 5 is watching that video for us. We didn't really consider which my favorite teams win the games. We didn't really detect the differences between two teams, A team or B team. As long as the scoreboard get changed the score, then we will extract the video clip. So we didn't really consider that. That could be one limitation in our study, since we have to move forward and to detect which team win, and so we providing those highlights for the fans who are also like to see their teams win the score. So this is the limitation. We also suggest that the future study, they could consider other variables in when they wanted to extract the highlights. And we will also consider about other models might also suitable to do this kind of the studies. So this is our overall study.